The recording has been started.
Mm-hmm. I think maybe we should wait a few minutes to join us more people, because we have quite a big gathering today. So let's just wait a couple of minutes more, and we start very, very soon.
That's perfect, Miriam. Thank you. Yes, we have like 21 people already in this webinar, so let's wait some more minute to let the other one join.
Lovely, yes. Mm. Mm. Yes, we are seeing that people are joining just right now. We're over 37. So just one more minute, and I think we should start the session. Mhm. Well, shall we start, Kike?
Yes, why not?
Good. So welcome everyone to a new Tech Dive series, where we take a deep dive into the barbara.tech platform and demonstrate how to deploy applications and models at the edge. We are delighted to have such a great group joining us today. Thank you for being here. And with me is Enrique Ramírez, our solution architect at Barbara. Together, we will walk you through the main aspects and key features of the platform. We encourage you to make these sessions as interactive as possible. Please use the chat to share your questions throughout the session. We will be addressing them with Enrique as we go along. And in addition, we will be sharing relevant content and resources related to today's topics. So make sure to keep an eye on the chat channel. So without further ado, it's my pleasure to introduce Enrique Ramírez.
Hello, Miriam. Nice to be with you and with all of you today. What a big amount of people. I'm very happy about that. Okay, to have so many assistants today. So yes, we are going to speak about the Barbara panel. Okay, in general, we are going to have a quite full agenda covering a lot of topics of the platform. So let me show here we have the element we are going to speak today. Okay, so we will start very briefly speaking about why use HAI. Okay, what is the HAI? How can you use it? How does Barbara help you to manage edge devices on edge platform? Okay, so will be our first point. As you can see, we start from the top level until the down level. Okay, so then in the second part, we will have a discussion about how to implement a couple of solutions, a couple of use cases in a Barbara Edge node. Okay, so we will cover two different solutions. We will cover the computer vision, and also we will see how to deploy a new NS solution in a Barbara Edge node using Barbara panel. Okay, and finally, once we have seen why do we use Edge AI? How can we deploy general use cases in our devices? We will go down to the platform and then we will go step by step, seeing the most important aspects of the platform. So how to provision new devices, okay, we will start seeing that. Then we will see how to deploy applications and model in the Edge node. We will be deploying application and model in the use case, but we will see it more with more detail, okay? Then we will see how to manage the Edge node, and we'll finally, at the end, we will finally see how to use the bash command, okay? The command that allows you to command a big group of Edge node in parallel. And finally, we will see one of our latest features we have in Barbara panel, which is the high availability functionality, okay? So let's start. Again, what Miriam mentioned some minutes ago, please, in case you have some doubt, don't hesitate to include it or to write it in the chat, and we will be answering to your question as soon as they arrive, okay? So let's start directly, okay? And let's speak about the Edge AI, okay? So the Edge AI at the end is something very simple, okay? Instead of having our workload, our processing, our application running on the cloud, okay, the idea is to deploy all these applications that make data analysis or all this AI model, deploy them in devices that are installed on premises, okay, so on the field. So we will move the processing unit from the cloud to this edge area, and we call the edge this site that is located near where the data is sourced, okay, it's originated. So this is basically what we understand by Edge AI. Deploy, run, and manage data analysis application and AI model on this distributed and on-premise devices. Okay, that's all. And that is exactly what we do in Barbara. Okay, so why should we move from the cloud to the edge? Because we are not, I would say, we are not, how to say, we complement the cloud, okay? The edge complement the cloud. It is not a substitute of the cloud, okay? There will be some company that still will keep their application running on the cloud, and it is fine. But there are some cases where the edge is more suitable for your needs, okay? What are these reasons to move from the cloud to the edge? So the first one of them is the cost, okay? The cost in the edge node is much more predictable. Okay, we can know how much will cost our solution when running on the edge instead of the situation when running on the cloud. Okay, I will put, for example, a basic situation. If we are working with a video stream, okay, we want to analyze video streams using AI model or whatever, the cost of uploading all this data to the cloud, analyzing it there, going down, it is very high. So in this situation, for example, it makes sense to use an edge device to analyze this data. The second key is the security, because obviously when you have your data on your premises and the data doesn't leave your premises, all the solution is much more secure, okay? So this is the main difference. When you move your data to the cloud, you lose the control of your data, then you have a public attack surface, and most of the cyber attacks in the last year have been done to the cloud, okay? So it is much more secure to use the HII in this case. Also, in the same situation when we speak about privacy, okay? If we don't want our data, not because security, just for privacy, we don't somebody else to host our data, we should keep this data on our premises using this kind of edge node. So it is also a good reason to move to the edge instead of working on the cloud. And finally, we are very happy about that because we have dedicated a lot of effort to a user interface. We want it to be as easy to use as possible, okay? And in fact, that is one of our best characteristics, okay? We have a friendly user interface that help our user, especially that users that come from the OT world, they don't use to work with IT tools to use the panel platform as easy as possible. Okay, so this is also a good reason to move from the cloud where all the tools are quite complex. Okay, we have this kind of IT software interface to like Barbara, which make everything easier. I will add also one more thing. Okay, which is the internet dependency. Okay. When you have your solution deployed on the cloud, you need the internet to be working, obviously, to have your use case working. Okay, in case you have some connectivity problem, your solution will stop working. That is something that does not happen on the edge. Okay, you can keep the process running on the edge. Okay, and even if you lose the connection with the internet, the application will still be working with the data they get locally and processing it locally. Okay, so the local solution will keep working even without internet. Okay, so well, this is more or less the reason why we should choose the edge to work instead of use the cloud. Okay, and I would like now to speak a little bit about the ecosystem of the Barbara Edge AI. Okay, why? Because at the end, Barbara, I didn't mention it before, but let's declare what Barbara is right now. We are an edge orchestration platform. Okay, that means that we can manage edge devices, we can control these edge devices, we can configure them, we can provision them, whatever, and also we can deploy application on them, okay, and we can configure this application. So we manage devices and we manage application. So what happened when some of our clients come to us? They don't need an orchestration platform, obviously. They need a solution for their problems, okay? And that is why we have this good AI ecosystem around the platform we provide, because this way we can we can receive the help of all these partners. For example, we have a partner that dedicate to the edge hardware. So we have some partners that, well, they manufacture this kind of hardware we can use as a Barbara Edge node. We can also some partners that develop AI model that you will find in our marketplace to be deployed on the edge node. We have some other partners that have application to perform data acquisition. We have also some other one that have complementary platform that can be deployed using Barbara. Okay, so this way, using this partnership we have, and also the help of our system integrators that are also our partner, we can provide a full solution to our client. And this is also something that is very important. Okay, so you don't have, in case you don't know how to process, how to analyze your data, what to do with your data to get a value, then we can help you thanks to this partner ecosystem. Okay. Now I would like to show you this architecture, because that is the main architecture we have in Barbara platform, and this way you can understand how the solution works. Okay, so at the end what we have is Barbara, an orchestration platform. Okay, composed like in two different, we have like two different areas here. We have this low area where all the edge nodes live. We can see here one edge node, okay, but obviously we will have more than one. This edge node is running on an industrial PC normally, or on a virtual machine, but it runs what we call the Barbara Core. Okay, that is our first product. This Barbara Core is an operating system developed by us. Okay, and it has a very important characteristics because it has been designed thinking about cybersecurity. Okay, so it has a lot of different cybersecurity measurement that we can see later. Okay, I will speak about it later, but this cybersecurity in the edge node. But anyway, these edge nodes connect using this Barbara code, connect to our API we have here. Okay, and above the API we have the other two products of the Barbara platform. The first one is Barbara Panel, and Barbara Panel is the interface we will use today to control these edge nodes and to manage the application running on them. And also the Barbara Marketplace, which is just an application hub that contains over 150 different applications, some of them provided by our partners we mentioned before, to be install on the edge node and to create that way different use cases. That is why we speak about one orchestration platform, many edge solution, because depending on what you deploy here, depending on the application that you deploy and how you interconnect them, you will create one use case or another. Okay, so the possibilities are endless. I would like to mention a couple of things more. The first one is this element we have here, the API, panel, and marketplace, can be deployed either on cloud or on premises. Okay, so today we are going to use the cloud solution. Okay, it is publicly available, but in some cases our client demands us to install an instance of the platform in their own premises, so they have a private solution for them. We can also do that. Okay, apart from that, I would like also mention sorry, check this plane we have here. Okay, this is we call the separation plane between the orchestration plane and the solution plane. Okay, why? Because we live in this area. We live in this area where we can control the edge node. We can control the application that are running here. We can check the configuration of this application using panel. Okay, but there is something that will not that you will never see user data in panel, okay, because the user data lives in this solution plane. So these applications are the one that get the data from your industrial sensor or machine or whatever, processes internally, send it to somewhere else, and it happens at this side of this plane, in the solution plane. So we never see your data here. We don't have access to your data. The only thing we do is installing application that this application have access to your data. Okay, so everything is separated. We will see it also later. Okay, so this is the architecture we have. Let's see the same thing using a different way, a different view. Okay, here we can see the edge node. The edge node, this is blue box we have here. Okay, then we have the field, and then we have the cloud or on-premise level, and also the remote level. Okay, so you can see we put an edge node at this level. Okay, it is orchestrated by or it is running the Barbara code firmware. Okay, and using this firmware we can connect to the cloud or on premises if the user demand that, but basically it's connect to Barbara panel. Okay, so this way you can access to panel remotely. Okay, in this plane, this control plane. Okay, we can deploy any marketplace or any user application. We will see later in more detail, but at the end you can deploy different application in the edge node. Okay, so this way the application have a dual way to get access. Okay, we can access this application using a VPN. We will see. Okay, we can access to this solution we deploy here remotely thanks to a VPN we have in panel, but also they can be accessed locally. Okay, if somebody is in the same network or a local network that is a edge node, they can access also this application model. So this is the way we work. Okay, just orchestrating this set of applications to create different use cases, right? So I think that is more than enough to let the people know what we do. Okay, I want to be simple today, so I will just move directly to the solution. Okay, I think that is the best example of the powerful feature you can find in Barbara. So today I will start it. I have prepared some edge node there. Let's speak later about how to provision one edge node, how to configure it, how to manage the network. Everything will be detailed later. Okay, but now I want to just focus on the most important thing. I have a node. It is correctly configured. It has access to the internet. I can control it, etc. So I will just start deploying a couple of use cases. Okay, so I will like to tell that thanks to our partners I mentioned before, we have not only the platform, but also a complete set of different solutions that can be applied to different situations, to different verticals in the industry. Okay, but as you can see, we have the level we mentioned before. We have the edge node here. Normally they are located at the Purdue level 2 or 3, okay? Then all of these edge devices are controlled using the Barbara platform, okay? We can have it either on cloud or in the enterprise network. And this way we can create different solutions, okay? Normally, the most common solution we work with are data operation and unified namespaces. Sorry. And I will stop my air conditioning because I think I will not be able to finish the session today if I don't do that. Okay, so we are going to speak about data operation and unified namespaces as a way to get the information from silos from different places in my enterprise, okay, and get all the information, normalizing it and putting it in the single source of truth. We will see it. Okay, we have also some solution called predictive analytics. It is something very similar, but now I have the data, okay, everything is, all the information of my company is in this data lake, and then I can apply some analytic using AI model or whatever to have some value about this data. We are speaking about, I don't know, predictive maintenance or detection of different aspects, etc. Okay, then we have a computer vision solution that is quite general. Okay, we can, depending on the AI model you apply to this computer vision use case, you can get other solution to different industrial, okay, the industrial vertical. Then we have also the software-defined automation, okay, as a way to automatize different tasks using software. And finally, the cybersecurity, okay. It is possible to deploy cybersecurity application in the edge node to convert this edge node in cybersecurity equipment to control the network or whatever. Okay, so we are going to start with this computer vision, okay, and I will tell you a couple of things about this use case. This is a general use case, okay. We are going to capture a video stream from a camera, okay. We have a camera here in our lab, so we can use an application called Video Reader to connect to that camera and get the video stream. Then we are going to use a YOLO. It is an AI model included in the Ultralytics application that help me to analyze the video feed and detect different pattern in every frame. Okay, so that will be the analysis we will do. Then the detected object and all the information related to this detection frame by frame is sent back to an MQTT broker, okay? And then we will visualize all this prediction in real time using the video player, and we will have also a dashboard to see all the prediction data has been stored also locally in a time series database as InfluxDB, okay? So this is what we are going to do, basically, get the video data, analyze it, and then visualize the new video output, and also have a dashboard with all the information about the detection, okay? The architecture we are going to use is this one, okay? As you can see here, we will have, well, we basically have one important thing, that it is the MQTT broker, which acts as the communication backbone, okay? We like to use this architecture with a messaging broker at the middle, because it helps me to decouple the video origin from the video sources, okay? The video sources from the video consumer, sorry, okay? So this way I can have one camera, or if I want to scale this to use 2, 3, 4 cameras, it doesn't matter. I just need to put more cameras connected here, and all the information will reach the broker, okay? Then we will have the player that is connected here to basically visualize the information we are receiving from the camera. And then we will connect here the AI model that perform the analysis. It will generate a new video output that will be seen also here, and also a telemetry in JSON format. So this telemetry will be stored in the InfluxDB database using an ingestor, which is an application that moves the information from the broker to the database. And finally, we will have a Grafana. Okay, and using the Grafana, we will have a dashboard to visualize all the information for this detection. Okay, again, in this case, we will use a general AI model to detect pattern, okay? But this is just an example. We can change this AI model to something more specific to your use case, to your need. So we have, for example, AI model that detects fire, or detect smoke, or detect liquid detection in pipe, or detect, I don't know, people that are not wearing the security, the protective element in the field, etc. So we have a lot of different possibilities for this AI model to cover different use cases. Okay, so I think I will just go directly to panel and let's start deploying this element. Okay, in an edge node to see everything working in real. Okay, so this is panel. Okay, this is the main view of our the main interface of our platform to manage devices. Okay, so I will just explain something quick because every line here is a different edge node. We can see where are they located. Okay, we can select any one of it and start working with that. Okay, so I will just select this one. Okay, and I am using this one just because I know this is a virtual machine anyway. It's a Barbara edge node, but it contains a GPU. And in this case, since I will be working with an AI model, I prefer to use an edge node without GPU. Okay, sorry, with GPU to that has a better performance than the one without. Okay, so this is the edge node. We have here all the information that you can see of this machine. Okay, everything is organized in cars, as you can see, and we have the node information area. We will cover that part later, okay, in more detail. Let's move here directly to this application and model area. Okay, we don't have anything here. Okay, so what are we going to deploy? We are going to deploy applications that are really that are available in our marketplace. We will use only marketplace application for this use case, and here you will see it is a very very big application hub. We have different possibilities here. We are going to use basically the video, Barbara video tools, okay? This kind of application. We will use the video reader, we will use the video player. We will use also the Ultralytics YOLO11 for GPU, okay? This is the application that contains the YOLO model I am going to use for analyze the data, okay? And then I am going to use other elements like an MQTT broker, okay? That is also available here, okay, to receive all the information. We will use this one, and also the InfluxDB database, okay, to store all the information locally. Okay, so I will just start, okay, and let's start very quickly just deploying the three first elements I need to present the use case. The broker, okay, I will publish the broker and will install it. Then I will install the video reader to get the information, and finally I will deploy the video player. Okay, so I will just start doing that. I will be back in this part where no models of application are installed in this node. It's empty. So let's start. I will just add a new application. I will select the broker. Okay, I need the broker to be installed in the first time. Okay, to start receiving information. Then I can select the version. I just need to follow this wizard because as you will see, all these applications we have in the marketplace contains a technical node here. Okay, and these technical nodes show me how to configure everything for this application, what are the every field demanded, etc. You will also find here some configuration example, etc. So this wizard is linked to this element, to this technical node. So all the information you have here is the same that the one you find here. Okay, so we will just configure it with the user, password, etc., whatever values I need. I will just use the default value, and I will send this application, okay? So once I send this application, check that I have a new card here in my edge node. You can see the name of the application, you can see the version, the status of the application, you can stop or status, okay? You can change the parameters you want to, okay? And finally, you will have a log viewer where you can see the actual status of the application by checking its logs, okay? So I can see that I have this MQTT broker running, okay? So this is the first thing I can see, okay? Then I will include here the video reader application to get the information from the cameras, okay? And to send this information to this broker, okay? So I will use this parameter to connect to the MQTT broker. And then here I will indicate that the camera I want to access is in this URL, okay? I want to use 50 values quality, 30 frame per second. I will call this video stream this way, video reader 01. I can change the name. This is just the name that I will use for connect to this video stream, okay? So I send this application, and again, now we will see I have a second application running on parallel, okay? And I can see in the log that it has been installed and it has been also connected to the broker, and we have the application is now working properly, okay? So now let's deploy the player, right? And this way, I will install the player. I will connect again to the broker. Now check my player as an interface, a web interface, so it will be available in this port, in the 5080. I can change the port if for any reason I need that. Okay, and finally in the player needs this configuration. This is the just kind of configuration that just indicate me, or I have to indicate here what it will be the name of the video stream I want to visualize. And this is something that we configured before for the reader. Remember, the name we use was video reader 01. So I send this application, and now I have the reader, the broker, and the player. How can I access the player? How can I visualize this original video I am receiving from the camera? Very easy. I just need to go to this information area. We will cover it later, but here we have this VPN IP here. So I just need to copy this IP to access remotely my edge node, okay? And then remember, my player was available in the 5080 port, okay? So I just need to open a new tab using the IP and the port 5080. I made a mistake. It is 5080. Here we are. So here we can see the original video, okay? And remember, this video comes from the player I have installed locally in a version that is deployed somewhere, okay? We can access the service remotely this way. And this is what I mentioned when I spoke about the separation between the solution plane and the edge on the orchestration plane. Okay, here in Barbara panel, we will never see the video. We will never see any user data. To access the user data and to get control over the user data, we should use the interface of our application. Okay, so here we have. This is the original player, the original video we are going to use for this analysis, right? Then I will call up my card, okay, so I have more space. And now I will just add the AI model that will connect to the broker, will read frame by frame the original video, will analyze it, and will generate a couple of things. A new video output and a telemetry, right? So let's do that. I will add this application. I will use the YOLO11 for GPU because I'm using a node that contains GPU. Then I have to configure everything to connect to the broker. I will leave like that. And I will have to, I need to check this configuration, okay? Here we indicate what is the name of the video input we want to visualize. It is correct, video reader 01. Then I have to indicate here what is the model, the AI model I am going to use to analyze the video. What is the name of the video output? It is important, YOLO11 video 01. It will be the name of the new output containing the detection. And then we have in this name for the telemetry and other information here for other parameters for the AI model. Anyway, we will just send this application containing the AI model. And now I can check also in the log that everything is working fine. It seems to be fine. It has connected to the broker, okay? It appears as connected, and now it shows the classes. So everything is working fine, and it is processing frames, as you can see. Okay, so what happened? If I go back now to my player, I will see the same original video that I saw before because I have to change here the configuration, and I have to indicate I don't want to visualize the video reader 01, but this one, YOLO11 video. Okay, so I send this configuration change, I go back to the player, and now in some second, I will start seeing the new video. Here we have it. Okay, so this is the new video generated by the AI model, right? And we have this information, but remember, the AI model was generating also one more string, a string containing all the information for every detection in every frame in a JSON format. Okay, so what we will do now is just covering the second part of this use case. We will deploy the InfluxDB database. We will deploy the ingester to move the telemetry from the AI model from the broker to the database, and finally the Grafana to have the visualization, okay? Let's do that very quickly, right? Let's just deploy the InfluxDB database. Okay, I will just deploy it quickly using the default values. Okay, and now I can also enter here in this database. I will do that. I will just copy the IP of my edge node using this data in the network card, okay? And then I have to check that the influx is available in the port 8086. So I have to open a new tab using the IP and the port 8086. I will be able to have access to this database, okay? I will just enter using the default values I provide. And now I am accessing to this database, and remember, it is not in the cloud, it is on the edge node. It is working locally on the edge node, and obviously it is empty because I am not moving any information from the broker to the database. To do that, I need to install the ingester, okay? And using this ingester, I will configure it to connect both sides, broker and database. I will use a configuration here. That is also a good thing we have in panel. We can have predefined configuration. Okay, so I just need to select it from this list and apply it. Okay, so it is very useful. I am just indicating I want you to search for this name in the broker, okay, to this stream in the broker, and I want you to store it in this bucket using this name. That is all. Okay, so I send this application, right? And now I can, as soon as it appears to be reading and writing, okay, I can go back to my database, I can refresh this view, and now I will see that now I have this data here, okay, so I have just started to receive information about the detections, okay. So final step to finish this use case, I will just add a new application, the Grafana one, just to connect to the InfluxDB database. It will be available in this port. And finally, now I will include here a ready prepared dashboard using the JSON format. So I created a dashboard, I exported it in JSON format, and now I'm going to include it here. So when the application starts, I will have a dashboard already prepared. Okay, so I can include it here. I send the application, and now we have here this Grafana app. I can open a new tab again. I can use the port 13,000 to connect to this Grafana, and now here I will see this basic dashboard, obviously, but well, a way of visualizing all the detection we are having here on real time. Okay, so all this information is flowing to the database. Okay, and now we have it on this dashboard, including the number of cars, person, traffic light, track, and frame by frame, you can see all this information. Okay. So, well, this is the first solution, okay, the computer-based solution. Again, this is just an example, okay? I want you to notice how easy it is to deploy, like one of these use cases is just 10 minutes, okay, to do everything remotely, to have the possibility to access the service remotely, and to configure or reconfigure everything in a single click, okay? So, I don't know, before going to the next use case, I don't know if you have any doubt or you want to, if you have some question about this, just please write it in the chat, and we will be happy to answer to you. Okay. So let's continue anyway, and I will move to the second use case I want to show you. Okay. This is an example, computer vision. The next example is UNS. Okay. And what is UNS? UNS is one of the trending topics we have nowadays in the industry. Everybody's speaking about the UNS, but UNS is something very, it's not complex. It's quite a simple thing, okay? At the end, what we want is to connect to every data source we have in a company, okay, to avoid having silos. Okay, imagine I have a company that has several plants located around the world. Every plant has different lines, different production lines, with different machine per line generating information about energy consumption, about the status, about the, I don't know, speed, about a lot of different information. So what we want to do with UNS is to get all this information from this lower level. Here we have the field level. In the field level, we will have a lot of different machine or sensor generating information. So we want to have an edge node located at the line level, okay, one edge node per line or per item, okay, getting all the information from this sensor connected to this line, okay. So we will have here like several edge node, one per line. Then we will have another level where we deploy an edge node at the site level, okay? So we will have one more edge node per plant receiving all the information we have from the lower level. So in case I have 3 different sites, 3 different plants, I will have 3 different edge nodes here. Then we will have the final level, the enterprise level, that it is normally one single edge node located at the enterprise level that is received all the information consolidated from the lower level, and it generates what we call the single source of truth. So we have like a repository of information, data lake or whatever you want to call it, okay, containing all the information generated in all the sensors, in all the machine in the company. But there are 2 more details important about this information. The first one, the information, the naming of this information must be unified. Okay, it must be. We must have a convention for naming variable or across my enterprise. So this way, if I call a temperature using a capital T here, then I will use the same convention for another temperature here. Okay, so this way you will have a uniform way of naming things in the company, and it is also very important when you want to apply processing or AI models or whatever to the whole information in the company. Okay, it should be it should have a unified new way of naming things. And the second part that is also important, apart from this naming convention, is that the information must be standardized. Okay, so we should standardize all the information and uniform it before putting it up to the single source of truth level. Okay, so what we will do in the example we have in panel, I will not deploy everything like the computer use case because just for the sake of time. I will just show you an already deployed solution, but it is very simple. Okay, what we have in our solution, we are simulating a food and beverage plant. Okay, we are going to use a UNS architecture in this food and beverage plant. We have only one, obviously one company with only one plant, and in this plant we have 2 different lines. Okay, so this is an architecture we propose for this case. Okay, this is a very basic case, but in this case what I'm going to use is an OpenCUA connector, okay, that is available in the marketplace to connect to any sensor or to any to machine that are available at this line level. We will read the information from this machine, okay? And here is where we will declare the way of naming things, okay? So the uniform namespace will be configured here at this connector. Then all the information will be published in another broker we have available in the marketplace. It is just the same broker I showed you before, but in this case, it also translates this way of publishing things in MQTT broker. It uses the Sparkplug format. The Sparkplug format is just a way of publishing information in the broker in a standard way. Okay, so this way we will be also not only unifying the naming, but also standardizing the information here at this level. Then at the local level, this is just the edge node, this square is the edge node at the line level. We will have again the InfluxDB database with the ingester I showed before in the computer solution example to get all the information from this machine to have it locally stored, and then we will have deploy and this dashboard for visualizing also information locally, okay? Then what we will do is bridging this broker to the broker in the next level, okay? In the side level, we will just have one broker here that is receiving the information from line 1 and line 2. And finally, we will have an enterprise level with another broker, and also in this case, an ignition instance. Ignition, inductive automation is one of our partners, okay? And we have the ignition application available in our marketplace. So here we will use ignition to have a single source of truth, including a dashboard to see all the information from my low machines. Okay, so I will just show you this use case. We have 4 different edge nodes, 2 in, well, one in line 1, another one in line 2, one inside, and one in enterprise. Okay, so let's review them. I will go back here, and I have created a group here, this solution UNS group, that contains these 4 edge nodes that are running different applications. Okay, so I will start just reviewing the line 1 edge node, and it has this application I mentioned before. Okay, we can find, we have the OPC UI connector, for example. Here we can see that we are connecting to this URL for this OPC UI server. Okay, and we are receiving information from several machines. For example, a Dove mixer machine located in the kitchen area in the line 1, okay? And then I can see the name of the different variables. Here is where I am unifying every name in this configuration. I have the motor speed, the vibration level, the energy consumption, the alarm status, etc. Then I have another machine, the conveyor belt, with some other variable. Then I have the oven, etc. Okay, so this application, this OPC UI connector is just reading the information from the machine and publishing them in this broker, okay? It is the broker that I will use to bridge this information to that level, but also to translate it to the Sparkplug format, okay? So I will just show you how is the information arriving to this broker. I will just need the IP of the VPN of this machine again, so I can connect to this IP. And now I will just use an MQTT Explorer, okay? I have it here, okay? So here we are. Okay, so I will just use this Explorer. I will put the IP of my machine here. I will set the correct username and password. And let me check if I did it. Maybe I did. I think this is correct. Oh, no. Here we are. So well, now I am connected, and here you can see we have this topic that contains all the information from the Barbara company, the Madrid side, and then we have 2 areas, packaging and kitchen, but we have the information from line 1, as you can see, and we can see the information about the line 1 in the packaging area and the line 1 in the kitchen area with the different machine. We are receiving information, okay? This is the normal information, okay, in a natural format. But also we have here the same information but translated to a Sparkplug format, okay? A Sparkplug format has some advantages. For example, it is compatible with a lot of third-party platforms like Ignition, for example. We are going to use it. But it has some disadvantage because the information is in binary format, so you cannot see it, okay? You cannot read it. That is why we have both of them together. Okay, as you can see here, we have information only about the line 1. But now, I will show you also the way we will use this ingester to move the information from the broker to the InfluxDB database. And finally, we will have a Grafana, okay, connected to this InfluxDB to have a dashboard with all this information. So I will show you that. I just need to open a new tab and enter in the port 30,000 again. So now I will be accessing to the Grafana we have here in the line 1. So I will see that I have this local dashboard with all the information for all the energy consumption data, the temperature, the vibration level, etc., that we are receiving in the broker. We have it here, everything, okay? So all the information about line 1 is here. I just need to connect to this session node to see that. But obviously it is bridged, not bound, so we can access other equipment we have. So for example, we can go to the site level, okay? In the site level, I just have the broker, okay? So now this broker is receiving the information from line 1 and line 2, okay? So I can connect to this broker, okay? Just copying this IP, right? And now if I disconnect from the other service and I change the IP and connect to the broker in this service, in this edge node, sorry, now I will see that I have the same information, but now I have the information from not only line 1, but also line 2. Okay, we are receiving all together. Okay, and finally, we have this enterprise level, okay, where all the information is converging here, and we have the broker and the ignition. Okay, so I will just show you again. I have to enter in this ignition instant. I will copy this, this one, this IP from the VPN, okay, and I can enter in the port 8088 where my ignition instance is running. Again, we are using an ignition instance that is running in the edge node. So I will just sign in to reset my license because it has expired. Okay, and now once I have entered, I will reset my trial, right? And now I can see, I can use the Vision Client Launcher, an application from the Ignition platform, just to access this single source of truth, okay? So I have it here. I will just select this application. And now it is connecting. You can see here the IP of the VPN of the edge nodes. And now when it starts, here we have it. Just a second. I will have the final dashboard with all the information, right? So let me move it here. Here we are. So you will see that now all the information from the line 1, from the line 2, in using the standard Excel format is arriving here. Okay, we have the line 1 diagram with all the information about the machines in the line 1. You can see all the data that we are receiving on real time, and also the line 2. Okay, we have some error statuses, okay, but all the information with the for every machine that had been considered line 1 and line 2. So this is a way of deploying a UNS use case using Barbara. Okay, we are just use this application like Ignition, like Grafana, like InfluxDB, but we are not tied to this one. We can use any different application. And that is one of the best benefits that we have in Barbara, because sometimes the client come and say, okay, I have 2 different plans, but in one plan we are using, I don't know, an Ignition instance, but we have any different plan, or some different plan where we are not using that, we are using another solution. So you can adapt to these particular cases. You can use the tool you want to use in the different levels. Okay, so you are not tied to a fixed architecture. This is absolutely flexible. Okay, so well, I think we have covered a couple of use cases, okay, that are quite relevant. And now I think we are going to start speaking about the platform, okay? Very quickly.
Enrique, how are
Yes.
you? We've been talking in the chat. We have various questions, and they're all about if they can deploy Docker contain in Barbara platform. I did say yes, but if you can actually expand on that, how they can either their own application, or how we can actually deploy third-party applications on a platform.
Yes, let's go to this. Let's go to this part, okay? because, well, I was going to start speaking about provisioning a new device and Barbara Core, but let's go directly to how to deploy application and model, and then we will go back, okay? So yeah, at the end, what we do best is deploying application, deploying models on the different edge remote, and everything we deploy is a Docker container, okay? So what we are doing is downloading Docker images to our edge nodes and running them as a container there. So what are the way of deploying applications and model in Barbara? Let's go back to panel, okay? And I will show you a couple of things. I will show you this application library we have here, okay? This application library contains every application that can be deployed in an edge node, okay? So again, we have two different origins. We have this one that are like marketplace application. Obviously, they come from our marketplace, okay? So we have here a lot of different applications that you just need to select and to press add to your library, okay, to include them in your library. We have, just to review some of them, industrial grade application to get the information using OPC-UA or Modbus or Magnet. We have connector for AIC 104 if you are in the smart grid sector. Some application to connect with the Aveva Pi, some integration with Snyder, etc. Okay, we have a lot of different solution to get information from the industrial machines or sensor, whatever. Then we have a storage solution like Influx, for example, or the databases to store the information locally. Applications, it is this business intelligence category are for process and visualize and analyze the data, okay? So we have here a lot of different possibility to work with data and process it somehow. We have also some artificial intelligence tool to deploy AI model or to deploy AI tools in the edge node. And finally, we have this virtual machine, okay? This is just a way of deploying a legacy operating system using this application that contains a virtual machine, okay? So it is sometimes common that some of our clients still run legacy equipment, so they still need this legacy software to run on their OS, on their edge nodes, okay? So we can deploy that. So anyway, for all of this solution, for all of this application, the only thing you need to deploy something, for example, this application to create a custom version for Windows, is just pressing here, add to library. Whenever you press here, add to library, okay, you can see that you do that. And from this moment, if you go back here, I will just reload this view, but if I search here for Windows Custom, I will see that I have it available right now. So this is the way of moving an application from the marketplace to your library. But now we can see we have other application called or marked as Docker application. What if I want to deploy something that is not available in the marketplace? Okay, that is why we have this Docker solution or user application. We just need to add a new application, include here the Docker compose file of my application describing the different service ports, etc. Okay, set a name, a version, declaring the compatibility with the different architecture, and that's all. I will have a new application, okay, that it comes from me, not from the marketplace, okay? And again, at the third place, we have these AI models, okay? We have AI model, a model library, so I can also not only use the AI models that are available here in the marketplace, I can also go back to this model. I can add my own model. Imagine I've been working with some data and I have trained an AI model using the framework TensorFlow, for example. So I just need to select the model I want to use, okay, for example, TensorFlow, select the engine I want to use for serving this model, and then uploading the trained model in the correct format and create that. That's all. Okay, so that way I will be able to upload the model and I will use one of these services to serve the model in the edge node. Okay, let me show you that. Okay, I will show how to deploy something basic. Okay, I will use this edge node, for example, that is already empty. So, for example, if I want to, we have seen how to deploy different applications. Okay, let's deploy something like a virtual machine. I can deploy Windows XP, for example. I like that because it's very old. So I just need to, again, configure the basic parameters of this machine and selecting the port where it's going to run, and that's all. I will have a new card with this Windows XP application, okay? And now let's deploy an AI model. In this case, I will select model, and I'm going to select something very basic, just a ResNet 80 model, which is a model, classic model to classify images, okay? So I just need to indicate the version I want to use. If I want to serve this model using GPU, okay, I can activate that parameter or not, okay? In this session node, I don't have GPU now, so I will leave it not marked. Then I have to indicate the port number where I am going to launch the server. So I will send the request to this port number. Okay, we have also a monitoring port number because we have the possibility to monitor the AI model in this port, and I can send the model. So this way you can see now we will have a different card. Okay, it's yellow because depends on the technology that you have declared, this case Python over Triton, but it is the same. I have the name of the model, the status, the technology. We have the status of the model, it is running, it has started, and now I can see the inference REST URLs in my edge node. So I can start sending requests to this URL to receive the prediction from my model, okay? And I also have this metric REST URL to connect another application here to get all the information from this AI model to the performance of the model. To do that, it is available here. It is just an application called ML Monitoring. I will monitoring. So we will have it here. Okay, so it is just to deploy this application from the marketplace, and you will have a beautiful dashboard with all the parameters from this model, how it is behaving, etc. And now, how can I connect to this Windows XP? It's very easy. Again, just open a real VNC viewer, okay, or something similar. I just need to get the IP of this edge node. Again, it's here. And now I will connect to this IP on the port 5900. So this way, it has opened in the other. Here we have it. Okay, so I just can connect to this system and start working with it or whatever. Okay, so it is a way of deploying AI model and deploying virtual machine, the same way to deploy use case or user application. Okay. Is there any more question? Not now?
Well, there's few, Enrique, but they're very, very particular to use cases. And I did mention that we can have, like, you know, after the tech day, we can have
Fantastic.
a scheduled meeting. So either, again, for the audience, if you do have a particular use cases that we can actually discuss in more detail, drop us an email because we'll be more than happy to set up a meeting with our experts. Yeah, but yeah. I encourage everybody else to send us, please, questions about
that is fantastic. Very fantastic. Yeah. Then we have just half an hour, okay, pending. So I like that because I like to have a good overview of the high level, okay, and then the lower level we can see it in detail, okay. But anyway, I will just show you the main aspect of the low levels, okay. We have spoken about how to deploy applications and model. We are seeing a basic example. I would like to speak a little bit more about the cards where we are using to reflect the application. Okay, we can see here the possibility. We have mentioned the application configuration. We have mentioned the application secret, okay, to configure the application, right? Then we have also the Docker Compose information, okay? We can see all the information, all the detail with the main parameters of the container, with the network it is using, with the port, everything is here. We can download this information, okay? And also, we can see also in this node information part, we have some cards that are related to these applications also, okay? For example, I'd like to speak about the global secret, for example. The global secret is a way of declaring, it's like environment variable for secret, because they have a higher level of cybersecurity or the security. So all this information is saved, encrypted in the platform. Not every role has access to this information. Normally here we put password, certificate to access several services, or confidential information for different services, etc. Okay, so we can declare here variable this way and these variables are available from the application. So in the code of my application, imagine I am uploading my own application, I have developed it, I can access to this information in the edge node, so I can use it to parameterize it. Okay, in the same way, I have this global config here. It is also the same concept, a way of declaring parameters that can be accessed from the application. And if you check that, it is just a JSON file. We call it global configuration because we can declare here whatever we want, and it is available for all the application, for every application running in my edge node. Okay, it is the different with this app config we have here. Okay, we have this app config because this app config is the same. It's a way of configuring things that can be accessed by the application. The difference is that here, if I declare something here in this app config, this information will be only available for this application, okay? Only for its own application. The global config here will be available for all of them, okay? Then we have the volumes, okay? As you will know, maybe the way of storing data locally in an edge node for a Docker container is using volumes, okay? And this way we can see here every volume that has been created by all the different applications that have been running in this equipment. So we can see the volume, we can see the site, we can see, for example, the information of which container is using this model. Okay, we can see also the information about the target, the service, the application. Okay, we can see how big it is. We can even, in the case that the volume is not being used, for example, these three first volumes are under use, okay, and I cannot delete them, but if they are not in use, I can delete the volume, okay, I can enter here, delete that volume this way, okay. So this card allows me to check all the volume and to create new volume manually if necessary, okay. Apart from that, we have also the Docker credential card, okay, and it is a very important, card, because think about, imagine I am a company, I am deploying or developing my own application. I have it in a Docker image. I have created a Docker image, and this Docker image obviously is in my private repository, okay? I don't want to use a public repository to share the image with everybody. I want to use my private repository and share it only with the people I want to share it, okay? So in that case, the node, when I deploy that application to an edge node, it has to connect to the repository to download the image. So in case you are using a private repository, how can you tell the node what are your credentials to access this service? Just here, you just need to add a new credential, select the repository URL, then the user and the password, and this way you can access to this repository, okay? So this is a way of using images, using Docker images that are available in your private repository, okay? So, well, more or less, we have seen the most important information for these applications, okay? You can see we have different cards related to them, okay? And then I'm going to move directly. I will go back because I want to start speaking a little bit about how to provision new devices, okay? So, to provision a new device, we need to select one of our compatible hardware, okay? So Barbara, that is very important, we are the hardware agnostic tool. We can run a Barbara node in different machines, okay? From different hardware, from different vendors, okay? In fact, here, you can see the whole list of the machines that are compatible with Barbara. But in general, as a resume, we can be compatible with any Intel-based machine or with any ARM machine, okay? So here you can see the full list. We have machines from the Raspberry Pi or the Advantech Uno, which are very light machine with low resources to the more powerful machine from the well-known vendors like Schneider, Albantel, or Dell, or Fenix Contact, Moxa, whatever. Okay, so you just need to select the machine you want to use. For example, this Advantech, and then you have here this Barbara OS, which is the Barbara core we mentioned before. And remember, we spoke about this has a lot of cybersecurity features included. We are going to speak a bit about it in just 1 minute. So I just need to download this firmware. I can do it here. Install this firmware. Once I download it, I will install it in my machine, and then automatically I will have a new edge node here in my list. Check that you can create a Barbara edge node not only using physical machine, but also using virtual machine. Okay, so you can you find here the firmware for the virtual machine in VMware for AMD and for ARM. We can also find machines for KVM or Hyper-V from Microsoft, with or without GPU, with or without BIOS. Okay, we have several possibilities to create virtual machines. Okay, so this is the way of provisioning the device. It's very simple, just installing the software in the machine, getting the ID of this machine, and then you need to add the node, putting the ID here, and the naming, and etc. Okay, so this is the way of registering the machine here. This is a very, very simple process. Let's continue. Okay, I wanted to speak about this feature about cybersecurity in Barbara Core. This is one of our strongest point, because normally that is one of the things that takes more time to our customer. Okay, they need to deploy a machine in an industrial plant. They just need to be sure about the machine is protected. Okay, so you have to close every port, you have to set up firewall, you have to create rule, you have to delete user, you have to close port, etc. Okay, so everything is absolutely included in the Barbara core. This core is an OS based on Linux, developed by us and compliant with the AIC 62443 specification for cybersecurity in industrial environment. Okay, so no root access, no user password access, all the ports are closed, okay? Only the necessary ones are open to communicate with the API of our services. There is no incoming communication channel, which make everything easier to when you are installing this machine in an industry to keep everything secure. All the file system is isolated, all the data is encrypted. We have secure boots, trusted provisioning, secure signage, auto updated, etc. Okay, there's a lot of different features to provide this cybersecurity in your edge node. So it saves a lot of time when deploying new machine. Everything is done out of the box. Okay, so apart from that, I would like to, we have spoken also about deploying application and model. Let's speak a little bit about how to manage the edge node, okay? So I will do it very simple. I don't want to bother you with details, but just to review, the possibilities to manage the edge node are endless. You can do anything, okay? You don't need the user or the SSH access or the user password access. You don't need anything like that, because everything can be done using panel. Okay, so for example, once you have your machine, you can obviously update the firmware. Okay, so in this case, this machine is updated, but even if you want to reinstall it, imagine you have some trouble with your machine and for any reason you want to reinstall your OS, okay, you can do that. Imagine you want to reboot your node, you want to shut it down, you can do deactivate, you can do anything you want with your edge node. Okay, speaking about the Docker system, you can prune the images, prune the containers, the network, you can restart even the Docker daemon, you can prune everything, so you have the full control of your Docker engine in your Barbara edge node. We have been speaking some of this card. Let me show you, for example, the general information card, where you have all the information about your machine. You can change the name of the machine. You can put this machine in group. We will see how later. You can check this ID of Barbara to register your node. You can set the different NTP server that the node will use to synchronize the timing. You can set the location of your machine on a map. you can do, well, anything you want, okay? So apart from that, you have also the information of the actual status of the machine on real time. Okay, we can see the temperature, the system load, the RAM, and the disk size. In fact, we can see that the disk is getting full, so we should do something to free space to the machine, okay? We can see also the evolution of this analytic. For example, I can select, I want to visualize the, I don't know, the disk size in the last 1 month, for example, okay? So I can do that, okay? And this way, I can change the kind of information I am seeing here. So we can see the evolution in the last month on the disk side, okay? And apart from that, we can do something very important here. Everything is covered in this network. Okay, this is the network card, which is one of the most important cards we have in panel, because we can control from this part, from this card, we can control everything that is related to the communication in the edge node, which is something very, very important. We can see here, for example, the whole number of the different interfaces that are available for this machine. This machine, this Advantech 3301, have 4 different Ethernet interfaces and 1 mobile interface. So I can enter here and I can configure everything. I can configure the static IP or the network or the gateway, or add IP alias, or set the primary DNS, or set more DNS, okay? Whatever I need, I can, for example, create VLAN, I can enter in the advanced area, and apart from enabling or disabling this VPN I showed you before, we can also establish the communication with the other wall using a proxy. We can configure the IP table, etc. Everything is very complete, okay? And there is something very important. Check that in every model here, we see this parameter, enable rollback. Why do we have it? Because obviously, if you are configuring your edge node remotely and you made a mistake, you will lose the communication with your edge node. And this is something you will never want to happen, because in that case, you cannot command it remotely anymore, okay? So when you set this parameter, okay, when you enable this parameter, if you made a mistake of configuration and the node goes offline, it will detect automatically that situation and it will go back to the previous valid configuration, so it will recover the connectivity again. So you are safe even when you are working with the communication just using this parameter, okay? So anyway, you can enter here and access to this network card and change any possibility or any configuration you want to change, okay? So, well, more or less, this is the thing we can do with a single edge node related to this configuration of the edge node, checking the status and checking the network parameters of the edge node. Okay, so let's continue. I think we have some more points pending, but not much. Okay. Well, we have the 2 very, very important one, batch command and high availability that makes the platform even better than what I had shown to you, okay? Because check, we have been working with just one edge node all the time, okay? But obviously, the normal situation is that I have a big number of edge nodes. Okay, if I am a big company, I will have, I don't know, maybe 20 or 100 or 500 different devices. Even people, companies that have thousands of different devices running on the deployed on the field. Okay, and if I want to imagine, I want to update the firmware to 500 machines one by one, it will be a good solution. Okay, so we can use what we call the batch command, okay? So every command that is available for a single edge node is also available to a group of edge nodes, okay? We just need to go back here to the edge node list, select the full quantity, the full list of edge nodes, the number of edge nodes I want to use. Anyway, in this case, I am selecting 17, okay? And I want to, for example, I don't know, I want to activate or reboot, or in this case, I want to update the firmware, okay? So I just need to select the command I want to perform. In the case, for example, here I am indicating what to do in the case that the edge node, the target edge node, is already updated, okay? In that situation, I can choose between reinstalling the same version or doing nothing, okay? So I can press next, and then I will see the resume the review of the bash command. I am going to update or reinstall the firmware in 17 edge nodes that are all of this. I can see that in this list, one of the edge nodes, this one, appears as offline. It is not connected. So what happened now? It is very interesting because normally what you want in this situation is that the command reach all the edge nodes, and it will happen. Even if it is online, the command will be stored in the system. So whenever this edge node comes it gets online again, recover the connectivity, it will get the command sometime later, and it will apply this command. So you don't have to worry. You can select the number of machines you want to command, send the information to them, and if some of them are offline by any reason, you don't have to worry about that. Whenever this node goes back to life, it will get the information. Okay, so it's very important. So this is why it makes very useful another functionality we have in panel. We didn't talk about that, but you can see here we can create groups. Okay, we have different groups containing different machines. Okay, so we have a default group. Okay, because all the nodes must belong to a group on only one group. Okay, so in the beginning, if I don't say anything, all my machine will belong to the default group. But then later I can just enter here and I can edit my group, delete them, create new one. Okay, and for example, here I have a group name called Tech Day Session that has this group, this edge node. I can move this element to another group. For example, I want to move this element to the default group, and then I will take this one, for example, and I will move this one to this. Okay, so I will apply that, and this way I am changing the group, and I can create group, and it is also very convenient because this way I can select, for example, the group UNS we have seen before. I can select all the machine from my group and command them in parallel. Okay. In the same way, I have the chance to add tags. I can see the tags are here in this column. Okay. So we can see that the machine has several tags included. That, for example, I can enter in this one, and in the information general info, I have the tags here. So I can create more tags or use one of the tags that hasn't been already used before. Okay, or I don't know, tech dive session, and I can add this tag. So this way, my machine will have different tags now. Okay, so this is another way of tagging my devices. Okay, because for example, now if I search for tech dive, I will see that it's only one machine that has been tagged this way. Okay, so it is a way of also creating group of element to be command in parallel using batch command. Okay, and finally, I would like to speak a little bit about high availability. Okay, because that is one of the latest features. We are very proud of it because well, it makes the platform even better, of course. Until now, we have been speaking about how to deploy application and how to create different use cases in a single edge node. Okay, but it has some problem. Okay, what is the problem of that? Imagine I am a user that has this situation. I have one or several edge nodes, like for example, this one. We have this element we have used to create the computer vision use case. And now I am going to reinstall my firmware or to apply a new software version that I have received. I want to keep my device in a secure state, so I have to apply this update. In this case, when the edge node applies a new version, it restarts. Okay, so I will have like some second or some minute where my service is not running. Okay, or imagine that my machine have a hardware problem and it's broken. Okay, so my service will go down. Or imagine I have some problem with the power of my machine and it's power off, okay, so I will lose my service, okay, and that is something that I don't want to happen. So how can I handle with that situation? The good thing is that I can now create clusters, okay. I can create a new cluster. I can add a new cluster just indicating a name, for example, tech type. I can enable cluster volume that are, remember the volume was a folder where the information of application is stored, okay? So I can create a volume to be used in the whole cluster, okay? And I can also create a virtual IP, okay, indicating this IP to access the service in this cluster. But what is a cluster? That is a good thing. A cluster is just a way of taking several machines and, for example, selecting this one, selecting this second one, selecting a third one, for example, imagine. And this way I am having a cluster using 3 nodes, okay? It is just exactly the same we have here. We have a cluster number, cluster 001, where we have 3 different machines. So we have a cluster composed by 3 machines that is acting like a single node, okay? So this way now I can add application and model to this cluster. In the case I want to update my machine or some of my machine goes down, check I have the information of the application and model that are running in this cluster, how many in this one, and how many in this one. And when I am deploying application in the cluster, I can select if I want to deploy in just one edge node or in several or all at once or whatever. The key thing here is that if some of the edge nodes that compose the cluster is lost, the tasks that are running on this edge node will move to the other nodes in the cluster. So we will have a service that is running 100% of time, okay? And this is something that is very important when you have critical services running on an industrial environment, okay? So again, that is one of the latest features, but it's we are very happy with that. It's working quite well, and this way we can have like 2 different levels. I can check that I can have, for example, in this case, I can have this cluster node 01. This is a Barbara edge node, and we are running some application here, okay, in the edge node level, but also this machine is also one machine that is included here, this one. So we have like 2 levels of application that run at the Barbara edge node level that has not high availability, and then the applications that are running on the top of the cluster, and they do have high availability, right? Just to finish, okay? We are just 3 more minutes to finish this session, okay? Thank you to everyone for your patience. I would like to ask a couple of things just to finish. As you can see, we have spoke about Barbara Core, the OS, cybersecure OS. We have been speaking about Barbara Panel, this interface we have been using to manage my edge devices. And finally, we also spoke about the Barbara Marketplace, the application hub. We have one more thing that I didn't mention. I think maybe Miren in the background has been sending some links to our academy, okay? The academy, you have it here. It is public right now. Oh, sorry, I made a mistake. Here we are. It is public right now, so it is you can access it without having a Barbara license. You have all the information we have been covering today and even much more available here. Okay, so you can follow our quick start guide to activate the license, put your first node to panel, all the information about the platform we have covered today, even with much more detail. We have also some tutorial to deploy solution. For example, here, I think Miren has shared with you this link so you can repeat the computer vision use case we saw in detail, and also information for developers. Okay, so in case you want to develop your own application and upload it to Barbara and deploy it in your, you can follow here the basic tutorial to how to create the Docker file, how to create the Docker compose, some limitation we have when programming for Barbara explained here, etc. Okay, so apart from that, you can see we have a visual code extension to be installed in your Visual Code and deploy directly. So you can start developing your application and sending it directly to panel and deploying to an edge node without leaving the visual editor, which is very comfortable. And we have also a Python SDK module that helps you to work with Python, for example, to train AI model. And the same way you can upload it to panel and deploy it to the edge node just from the Python code, which is also very convenient. Okay. So apart from that, I will just finish. We have also the information from our API. So you can integrate your existing data pipelines, okay, or your existing pipeline to our API without using panel if you want to. Okay, so you are not, you cannot, you can not use panel. You cannot use this user interface. So you can just connect your existing pipeline to this API. We have all the information here, so you can automate your pipelines. Okay. So well, I think that more or less that is everything. Miren, what do you think?
Well, it's been pretty intense. We do have some last questions. One is from Agustin. He says, how long does it take for an edge node in a high availability cluster to replace a fail node in the same cluster?
Well, depend on the problem. Okay, it depends on the type of crash, but it not takes long. Okay, normally that's why we call it high availability. Okay, the services automatically move to the other cluster. Okay, so it is only depending on the number of edge nodes you have in the cluster. Okay, it is not the same to have a cluster with 2 edge nodes than one with 3 or 4 edge nodes. Okay, the more edge node, the more resilient, the more powerful is the cluster. But answering to your question, I would say seconds. Okay, to move the task from one cluster to the other, and as a result, the user will not see a stop in the service you have deployed.
Absolutely. Just final questions, because we've been chatting a lot, and we're talking about applications in the marketplace. Yeah. How often do we publish new applications? How often do we update versions? Because this is something very important to all. Can you tell us more about that?
Well, yes, in fact, we have a good rhythm of uploading or publishing new applications in the marketplace. I would say it depends on the month, okay, but I would say that the rhythm is about 5 to 10 new applications every month, okay. In fact, we used to publish them also in our marketing channel. Miriam can speak about that, okay. But this is more or less 5 or 10 different applications, and we want our user and our customer to influence us in the kind of application we publish in the marketplace. Okay, so sometimes it happens, it is very common that if some of our users need some application to be included, we automatically add it to the marketplace. Okay, so we are influenced by our customer to create the application roadmap for the marketplace.
Lovely. And just final questions about the licensing model of Barbara. What do we offer? Can you tell us a bit more about our licensing model?
Well, the licensing model of Barbara is not a secret. Okay, it is published in our website. Let me show you. Okay, so we have here this pricing, and you can see we have like different way of licensing with different characteristics, but to resume everything, what defines the licensing in Barbara is the workloads. Okay, so what is a workload? A workload is just an application that is running on an edge node. Okay, so depending on the number of applications that run in your organization, okay, you will need one license or other. Okay, so well, we have some functionalities that can be added or this kind of thing, but the main values are the workload. And for example, using the essential, which is the lowest license, you can use 10 user-defined workload what are user-defined workloads? Basically, the application that you add by yourself, okay, or the AI model that you add by yourself. These are this user application, okay? And then we can use also 50 standard marketplace that are standard applications that come from our marketplace. So in total, you can have 60, okay? And well, if you have 5 applications in 2 devices, 5 and 5 are 10 workloads, okay? So this is the way of calculating what licensing do you need.
We do have another question from Rick Ben. Says, for the cluster function, do those edge nodes be running on the same IPC or a different IPC?
Well, I was thinking about IPC, industrial PC. Sorry, Miren.
Sorry, it was my fault. It was my fault.
Industrial PC, yes.
Industrial
Very good.
PC.
A very good question. Yes, I am a little slow at the end of the session. Yes. No. You can use any edge node you want. They don't need to be the same hardware. Okay. And in fact, when you create the cluster, okay, you can add your cluster or the node that compose your cluster, okay, you can, let me show you, you can add labels, okay, for example, to characterize these edge nodes. For example, if you have one of machine in the cluster that has GPU, okay, you can declare here GPU true, and when you are deploying application into the cluster, you can select, I want this application to run in only GPU true devices, okay? So you can use different machine with different characteristics, you can tag them this way, and you can tell the application where do you want them to be run, okay? So you can say, I don't want you to run in this kind of machine, only in this one, okay? So the possibilities are really endless. It is a very, very good functionality.
Okay, can we have another one? No, just we say thanks. So it was industrial PC. We just, it's the end of the session. Well, if you have more questions, it's very easy to reach us out, email us. We're happy to answer to you. Just thank you all for joining us today. It's been a long session, but we have, we were 50, now we're 30 people. So it's very, very thankful for staying with us. And I would like to ask you to take a minute to complete our feedback survey. Your input help us to shape better webinars and tech sessions. So we will be very happy for you to fill in. And thanks again. And we look forward to seeing you in the next deep dive session. Thanks to all for staying with us. Thank you, Enrique, for everything.
Thank you. Thank you to all of you for coming. Thank you very much.
Bye-bye.
Bye.